Welcome to Ask and Learn.
Okay, so for this problem, we are considering a cycle ABC. So let's firstly draw the PV diagram. Sorry. Yeah, I want to draw the PV diagram. All right. So this is P, this is V. The process AB is at constant pressure, constant BC is at constant volume, and we don't know about process CA. But let's see. So AB is constant pressure. So constant pressure is just the horizontal line, and the constant volume BC is just the vertical line, and the other process is just the let's see, just a curve. Okay, and this will be A, state A. This is state B, and this is state C. So this is the direction of the flow. It is clockwise. All right. So yeah, this is a sketch of the PV diagram for this cycle. And the part B, we need to find out the work for process CA. The method I found for this part is kind of tricky. So we want to find out the work for process CA, but we firstly need to look at the process AB. Uh, the work done in process AB is pretty easy because it is constant pressure. So WAB is pretty easy, equal to PA times VA minus, I'm sorry, this is PB minus, uh, right, yeah. PB minus times VB minus PA times VA, okay? And PB equal to PA. So basically just equal to PA VB minus VA, right? And we also know that PV equal to N times R times T for any state for ideal gas. So basically, for this expression, we have so PA times VB will be equal to N times R times TB minus N times R. So this is PA times VA times TA. We already know the temperature at state A and state B, and R is a constant, and is given as 2 moles. So we can just plug in numbers and find out the final result for WAB. Well, the number I found is hold on, let me check. It's 1. It's 1660 joules. Yep. And then we need to use the first thermal law. Uh, so W equal to Q minus delta U. This is the first thermal law. And W is the work done by the system. U is the heat flowing into the system, and delta U is the change of the internal energy. So for the three processes, we have these expressions. I mean, and we have this. We can apply this formula to all of the three processes. So we basically have WAB plus WBC plus WCA equal to the the total heat in the cycle Q, which is this one. Okay. and minus delta U. But because we are considering a complete cycle, so delta U will just equal to 0. So it's just 0. I just label that this is delta U. Okay. So we already know this delta WAB and WPC. If you look at the PV diagram, WPC just a constant volume. So WPC is simply 0. This is 0. Okay. So the only unknown thing in this formula is WCA because we already know the Q. Okay, yeah, the Q here is the heat flowing into the system, and the information we got from the problem is 800 joules flowing out of the system. So basically, the Q is negative 800 joules. Okay, so we can just move this WAB to the right hand side, and WBC 0. So we can get this WCA. So finally, WCA equal to negative 800 minus 1660. So the final result is negative 2460 joules. All right.